So another general term that is used to describe a part or parts of a bridge is what we call these miscellaneous terms. So before we start on engineering a bridge, it's worth it to know first, it's worth it to familiarize ourselves first on these miscellaneous terms. So the first of the miscellaneous terms that we will study is the vertical clearance. So what is a vertical clearance? Vertical clearance is the minimum distance between the structure and the highway underneath, such as this. So this is the vertical clearance. So usually we provide vertical clearance whenever we build a bridge over a highway. So there is a highway underneath a bridge. So on those cases, we usually provide vertical clearance such as this, the distance between the highway and the soffit or the bottom of the bridge. So the purpose of having a vertical clearance is to allow the traffic or the vehicle to underneath the bridge, to allow the vehicle or traffic underneath the bridge to safely travel underneath the bridge to provide adequate space, especially those vehicles of greater or great heights, to allow them to safely travel underneath a bridge so that there will be an adequate space for them to safely travel beneath a certain bridge. So that is the purpose of having a vertical clearance. So usually you can see vertical clearances on structures such as this or in tunnels. Whenever you traverse a tunnel, you can also find this. And any roads or highway that has a vertical limitation. So we usually provide a vertical clearance. So another miscellaneous term that describes a part of a bridge is what we call or what we call dead loads. Dead loads are permanent loads placed on a structure due to gravity of the structural and non-structural elements. So these dead loads are actually part of the bridge that are uh, actually fixed in position. So some example of dead loads are the weight of the bridge itself, the weight of the components of the bridge itself, like the weight of the deck, the weight of the girders or the primary members or the secondary members, the weight of the piers, the weight of the footings, etc., etc. So those are some example of the dead loads that are that comprise the bridge itself. So again, dead loads are those loads that are permanent, meaning these are the loads that are being carried by our bridge that are fixed in position. So that is the keyword there to define dead loads. There are loads that are fixed in position, meaning their position don't vary with respect to time. So another miscellaneous term that we must study is the superimposed dead loads. So these superimposed dead loads are dead loads placed on the structure after the concrete deck has hardened, like the bridge railing, the sidewalks, the wearing surface, etc. So superimposed dead loads are actually still dead loads, but the main difference is these superimposed dead loads are dead loads that are placed over our structure, over our bridge, after the concrete deck has hardened. Or in other word, in other words, these are dead loads that are just placed on top of our structure. So they are not integrally part of our structure or bridge, but they are just placed over our structure or bridge. So that's the main difference between superimposed dead loads and dead loads. Dead loads are those loads that are being carried by our structure, by our bridge, that are integrally part of our structure. While superimposed dead loads are those dead loads that are just placed on top of our structure or bridge after the concrete deck has hardened. So some examples of superimposed dead loads are bridge railings, sidewalks, and wearing surface. Another miscellaneous term to define a part of a bridge are live loads. Live loads are temporary loads placed on the structure such as vehicles, pedestrians, etc. So the main uh, the key word to define live loads is these are the loads that are being carried by our bridge, by our structure, that has varying magnitudes and varying positions. Or in other words, they are not permanent in position with respect to our structure, with respect to our bridge. So some example of live loads that are being carried by our bridge or by our structure are vehicles. So obviously vehicles change in position as it travels our bridge, our roadway, obviously. So therefore, they can be considered as live loads because, as we defined a while ago, that live loads are loads that are being carried by our structure that are not permanent, that have that has or that have not uh, that have no permanent position. Sorry. So these live loads are those loads that are being carried by our bridge, by our structure, that have no permanent position or no permanent magnitude. So one example of that uh, is a vehicle traveling along our bridge or a pedestrian traveling our bridge. Obviously, they are not part of our bridge. They are using our bridge, but they are not fixed in position. Their position vary with respect to time. So if they don't have a fixed magnitude and fixed position, therefore, we can consider them as a live load. Another miscellaneous term for us to be familiar is load rating. Load rating is an analysis of a structure to compute the maximum allowable loads that can be carried across a bridge. So this load rating are actually those signs that you can see when you enter a particular bridge. Like, for example, there is a signage there that says 10 tons. So that means that the maximum allowable load or weight that can use that particular bridge uh, is up to 10 tons only. So those vehicles that have a weight over 10 tons, they cannot use that particular bridge. So that 10 tons, that signage that we usually use when we enter a bridge is what we call the load rating. So this rating uh, is actually found by the analysis of the structure, by the analysis of a bridge. So we usually analyze a bridge, we usually design it in order for us to know what maximum load can it accommodate. So usually we are doing this on bridges or structures that are old, that are already old, because as we all know, the strength of a bridge, the strength of a structure deteriorates as time goes by. So therefore, we must continually analyze it in order for us to know the reserve or the available strength that it still have, so that failure of that particular bridge or particular structure will be prevented. Another miscellaneous term that we must be familiar with is the sheeted pit. So this term actually we already found uh, an overview of this particular term here, the sheeted pit. So this is actually similar to the term that we have described a while ago, which is the sheeting. So what is a sheeted pit? So a sheeted pit is a temporary box structure with only four sides that can be used as an earth support system in uh, in excavation for substructure foundations. The bracing elements used inside a sheeted pit to keep all four sides rigid are called wales, which run along the inside walls of the sheet piling. and struts, which run between the walls. When this type of structure is used where the ground level is below water, the sheeted pit is called a cofferdam. So as I've said before, we already had an overview of the definition of sheeted pit when we describe sheeting on the substructure component. So sheeted pit looks like this. So we usually use this sheeted pit as a temporary box structure to prevent uh, erosion of earth to the excavation. So we usually use this for excavation works to prevent the surrounding soil from eroding to the excavation. So this is still composed of vertical planks interweaved together and then provided by additional supports, which are called wales. So these are the wales and struts. So this is the strut. So the wales run along the side or the inside walls of the sheet piling, and the struts run between the walls. So the wales are the ones that holds the vertical planks together, while the struts prevent the 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 vertical planks from eroding as it supports the earth beneath it. So if this sheeted pit is used on locations where the ground level is below water, the sheeted pit is called a cover dam, just like what we have seen a while ago on the sheeting term on the substructure part of our discussion. So you have seen there that the vertical planks are used on a ground below the water. So that is what we call a coffer dam. We usually use that in order for us to be able to construct the foundations of a bridge that is being constructed in a body of water. So last miscellaneous term that we must be familiar is the stage construction. Stage construction is a construction that occurs in phases, usually to permit the flow of traffic through a construction site. An example would be a bridge replacement project where one half of the structure is removed and replaced while traffic continues over the remaining portion of the structure. So when we say a stage construction, this is just a construction that occurs in phases with the purpose of not preventing the flow of traffic. So its main purpose is to prevent the stoppage of the flow of traffic, even even if we are having a construction activity. So one obvious or one famous, should I say one noticeable example of stage construction is whenever our local public works agency, fixes our roads. So as you notice, whenever our local public works agency fix our roads, they usually don't do it on the whole road. They usually do the construction works on only half of the road in order for the traffic to still flow on the other half. So after they are done constructing, paving the road on one side of the road or the highway or the road, after they are done paving the road, the half of the after they are done paving half of the road, they will now start constructing on the other side of the road so that the traffic will now flow on the side of the road that is already finished. So that particular way of constructing is actually what we call stage construction. Construction that occurs in phases not uh, with the main purpose of preventing the stoppage of traffic flow. So those are the miscellaneous terms that we must be familiar before we start our study of bridge engineering.